Occurrence of metals. Metals occur in nature in the free as well as in the combined states. The most unreactive metals, that is, which are not affected by air and water, like silver, gold and platinum, are generally found in the free state. Most metals, however, are found in the combined form as minerals. We will now learn about the most common forms in which different metals occur in nature. Native form: gold, silver, platinum, copper and mercury. In the combined form as oxides, as sulfides, as halides, as carbonates, as sulfates, as phosphates, as nitrates. Difference between an ore and mineral. Minerals from which the metals can be extracted conveniently and profitably are called ores. An ore contains high percentage of metal. Thus, all ores are minerals, but all the minerals are not ores. For example, hematite, iron oxide and iron pyrite are the minerals of iron. Iron pyrites contain small amounts of iron, so it is only mineral of iron and not an ore. On the other hand, hematite, iron oxide, is an ore of iron. Let us now learn about mining of the ore. Most ores generally occur deep inside the earth. Some may occur only a few meters under the earth's surface. Mining is the process of taking out the ores from the mines. When an ore occurs near the surface of the earth, it can be directly dug out. Such mining is termed as open pit mining. When an ore is taken out from greater depths, then the mining is termed deep mining. Extraction of metal from its ore. The process of extraction of metals from their ores is called metallurgy. Ores are generally associated with non-metallic impurities of earthy and rocky material. Such materials are called gangue or matrix. The process of extraction depends upon the nature of impurities present in the ore. Common steps involved for the extraction of metals may be listed as crushing and grinding of ore, concentration of ore, extraction of metal from ore, and purification of metal. Let us begin with the first one, that is crushing. Extracted ore often occurs in big lumps. It is essential to break it into smaller pieces. The lumps are crushed to smaller pieces by hammering in a hammer mill or by help of a jaw crusher. We will next learn about grinding and pulverization of the crushed ore. The crushed ore is then finally pulverized to fine powder state in a stamp mill or a pulverizer. We will next learn about concentration of ore. The process of removal of earthy and rocky material from pulverized ore is called concentration. Impurities associated with ore are collectively called as gangue. An ore can be concentrated by few methods. Let us discuss them one by one. Hand picking. Do you know what happens in hand picking? Bigger impurities such as stones, etc. are picked manually. Let us learn about the second method, that is, gravity separation or hydraulic washing. When the ore particles are heavier than the gangue particles, the ore is fed into a running stream of water and impurities are washed away. This separation is by way of gravity or levitation method and is commonly used for oxide ores such as hematite and native ore of gold, silver, etc. In order to concentrate the ore in bulk, a slanting vibrating wooden table with wooden strips called rifles is introduced in the process. Such tables are termed Wilfley tables. The ore is continuously washed with a fine spray of water and the rocking motion sieves the heavier portions while allowing the impurities to filter away. Sometimes in the gravity method, a hydraulic classifier based on the gravity method is used. Ore is agitated by a powerful current of water pushing upwards through the bottom of a conical reservoir. The heavier ore particles settle down and are continuously removed from another opening near the bottom, while the lighter particles are washed away by water. Hydraulic classifier. We will now learn about the next process, that is, froth flotation process. This method is used for concentration of sulfide ores. This method is based on the preferential wetting properties of the ore with frothing agent and water. The crushed ore is added into a tank along with water and oil as shown in the animation. The water in the tank is agitated by blowing in compressed air. Froth is formed in this process. The sulfide ore particles stick to the froth and rise to the surface along with the froth. The gangue particles are left behind in the tank. Let us now learn about another method of separation of metals from their ores, that is, magnetic separation. This method is based on the difference in magnetic properties of ore and gangue. Ore having magnetic impurities can be concentrated by this process as shown in the animation. We see here that powdered ore is dropped on a moving belt. When ore passes over the magnetic roller, the magnetic impurities are attracted towards some magnetic roller and hence form a separate heap. Non-magnetic impurities are not attracted by the magnet and fall apart. In this way, we get two distinct heaps. One heap is that of magnetic material and another is that of non-magnetic material. So, in this way, ore gets separated from magnetic impurities. We will now learn about leaching. This is a chemical method for concentration of ore. Powdered ore is treated with a chemical that can dissolve ore but not the impurities. Bauxite is concentrated by this method. For example, bauxite, that is Al2O3 2H2O, is the impure form of aluminium. The main impurities present are Fe2O3 and SiO2. Iron oxide gives red color to this ore. To obtain sodium aluminate from bauxite ore, it is first treated with sodium hydroxide. Aluminium oxide reacts with sodium hydroxide to give sodium aluminate and water. Iron oxide, being insoluble in sodium hydroxide, is easily separated, but SiO2 reacts with sodium hydroxide to form sodium silicate. When the solution of sodium aluminate and sodium silicate are treated with water, then the precipitate of aluminium hydroxide, that is AlOH whole thrice, are separated and sodium silicate will be left in the solution. The precipitate of aluminium hydroxide is separated from the solution, which gives aluminium oxide on heating. Sodium aluminate reacts with water to give aluminium hydroxide and sodium hydroxide. Aluminium hydroxide on heating gives aluminium oxide and water. Leaching of silver ore. Leaching process is also employed in the recovery of some precious metals. Silver is extracted from its ores, argentite, that is Ag2S, horn silver, AgCl, by cyanide process. The finely powdered concentrated ore is treated with a dilute aqueous solution of sodium cyanide, and a current of air is passed through the solution. Silver present in the ore gets dissolved due to the formation of soluble sodium argentocyanide complex, that is NaAgCN whole twice. With horn silver, that is AgCl, the reaction of sodium cyanide can be written as AgCl reacts with 2NaCN to give NaAgCN whole twice plus NaCl. We will now learn about extraction of metal from concentrated ore. This process involves few steps. First is conversion of ore into metal oxide. This can be done by the few methods. Calcination. It is a process of heating an ore in a limited supply of air or in the absence of air at a temperature just below its melting point. For example, when hematite is heated, it is converted into its oxide. When ferrous carbonate is heated, we get ferrous oxide and carbon dioxide. This method is used for hydrated or carbonate ores. Let us now learn about another method, that is roasting. In this process, ore is heated strongly in the presence of air at a temperature below its melting point. On heating strongly, metal sulfide in air is converted into its oxide. For example, when zinc sulfide is heated, it is converted into zinc oxide. We will now learn about reduction of metal. The metal oxide can be reduced to metal by the few methods. Let us begin with reduction with carbon. When metal oxide is treated with a reducing agent like coke, it is reduced to a metal. Flux is also added to remove impurities. Substance which combines with gangue to form easily fusible material is called flux. The fused material, that is flux plus gangue, is called slag. For example, when zinc oxide is heated with coke, it is converted into metal and carbon monoxide. When lead oxide is heated with coke, it is converted to lead and carbon monoxide. Silicate impurities and flux combine to form slag. Slag, being lighter, floats on the surface and can be removed easily by pouring. We will now learn about reduction with aluminium. Aluminium possesses low value of ionization energy. Aluminium is also more electropositive than chromium, manganese or tungsten. Hence, it is used as reducing agent. This process is called as aluminothermy. For example, chromium metal can be obtained by reducing chromium oxide with aluminium. Electrolytic reduction. This method is used for highly reactive metals like aluminium, sodium, potassium, calcium, etc. Purification or refining of metals. Metals obtained after reduction of metal oxides contain certain impurities. The method used for refining depends upon the nature of impurities and nature of method. Distillation. Distillation is applicable where metals have very low boiling points. Zinc and mercury have comparatively lower boiling points than the impurities and therefore can be separated from them by distillation method. Impure zinc is heated in a retort to such a temperature that zinc metal is vaporized. The vapors are then condensed in a receiver to get pure zinc metal. The impurities do not get vaporized and are left behind in the retort. Metals having low boiling points are purified by this method. Zinc, cadmium and mercury form vapors very easily. Hence, these are purified by this method. We will now learn about the method of purification of metals, that is, liquation. This method is used to purify metals like tin and lead which have melting points lower than those of their impurities. Liquation involves heating the impure metal to a temperature just above the melting point on a sloping hearth of a furnace. the molten metal flows down the slope, leaving behind the solid impurities whose melting points are higher. Liquation is suitable for the purification of lead and bismuth, which have low melting points. Next method of purification of metals is electrolytic refining. It is the most important method used for refining metals. Metal which is to be purified is made anode, whereas a thin sheet of pure metal acts as cathode, as shown in the animation. Aqueous solution of metal salt is used as electrolyte. For example, in case of refining of copper, impure copper is connected to the anode and pure copper is connected to the cathode. A copper salt is used as an electrolyte. On passing electrical current, copper ions move towards the cathode. Pure copper is deposited on the cathode and the impurities are collected at the anode. We will now learn about the next method of purification, that is Van Erkel method. Zinc and titanium metals are purified by using this method. Impure metal is converted into double compound, which is then decomposed on heating to form pure metal. Titanium reacts with iodine at 230 Kelvin to form titanium iodide. Titanium iodide, when heated at 1760 Kelvin, forms titanium and iodine. Let us now learn about one more method of refining of metals, that is zone refining. This method is also called fractional crystallization method. This method is used for purification of silicon and germanium metals. It is based on the principle that impurity has greater solubility in liquid than in solid state of metal.